Hi guys, how are you? Welcome to both of you in this next new session. So two more people maybe will join that class maybe later. Uh, so I just need short intro of yourself, and then I will give you my short intro, and then we will start our lectures. Start from Mr. Abdul Hadi, Abdul Ahad. Uh, I think Mr. Ahad is not
Assalamu
on the
alaikum.
call.
Hello.
Assalamu alaikum.
Assalamu alaikum. My name is Sayyid Abdul Ahad. I am currently working as a design and application engineering at Photon Engineering, and I am from basically Lahore, Pakistan.
Thank you. Thank you for joining the class and welcome to the new sessions. Hopefully, we will get the knowledge that you are expecting from my side. And I also expect that you will practice and will deliver as per my expectations. Then I move to the Mr. Kazi.
Assalamu alaikum. This
Walaikum
is
assalam.
this is Kazi Masum from Bangladesh, and I am doing business in this sector. We are installer in Bangladesh. By education, I am a civil engineer actually.
Okay, thank you. Thank you, Mr. Kazi, for joining that class and welcome uh, to you in that session. I'm very hopeful that you will get the knowledge you are expecting from my side. And also, I am expecting that you will deliver and you will perform the task as by assign in that sessions on the regular basis. So, Uh, from my side, I'm Azizul Hassan. Basically, I'm as a his solar design engineer working in the international company based in South Africa, UAE, and Pakistan, Mina Consultancy and General Contracting. I'm working as a design engineer in the solar field from since 2019, and still I'm working there. And I'm doing the freelance services as a design engineer with different individual clients and also with the companies. And also, I'm doing that training sessions uh, due to some uh, uh, you can say that due to the overburden and other things, maybe I will discontinue or maybe I will give the space between these sessions in the next batches uh, because I'm just doing my own business in the freelance services on small level, but because I don't have any my own team in the designing field, I'm just doing myself like on the SketchUp, AutoCAD, PVsyst, and other things, and like calculations, BOQ, other things working separately. So that is why I'm too much busy. Basically, this session is start from the 15 December due to some health issues and other things. I have to delay these sessions. So that is why I'm just giving you that small intro. And I have delivered two sessions, back sessions, one and two. Uh, one session I have like share with the one person guy from the Kenya, and the second batch I have delivered myself as a separate one. So that is when the third sessions. So most of the people have also know me on the LinkedIn sessions. So So I'm very hopeful that I will deliver a good knowledge and you will uh, see the difference when you are completing these 20 classes in your expectation and your knowledge. Uh, Welcome, Mr. Greg, in the class and the sessions. I need your short intro from your side, and then I will give myself the short intro to you, and then we will start our lecture because Mr. Abdul Ahad and Mr. Kazi has already given their small intro. So I need for the our understanding, our uh, know each other. I need short intro from your side, Mr. Greg, kindly.
Uh, thank you, Aziz. I hope I'm pronouncing it well. Or let me say Hassan, that's a bit easier.
Okay, okay, no
Uh,
issue, no issue.
my name is Gregory, short for Greg. I'm from Kenya. I'm
Okay, thank
a
you.
project engineer focusing on solar design, installation, and commissioning.
Okay,
Just
thank
here
you.
to knowledge, particularly on the design aspect. Yeah.
Okay, thank you. So, Mr. Greg, I have already given a short intro to Mr. Ahad and Mr. Kazi, but I will give you the short intro to you. That myself, Azizul Hassan, you can call me as a Hassan, no issue. I have basically 7 year experience in the solar designing field on the local level, and then in the international company, which is based in the South Africa and UAE in Pakistan. I'm currently working as a solar design engineer and the intermediate levels. Most probably promoted to the senior engineer in that session. And I'm currently doing my small business in the freelance services, to the individual clients on the international level and the local levels, and also the different companies in the international and local levels as a solar design service, like the layouts, PVsyst, and other things. And also, I'm doing that sessions, training sessions, free and also the paid one, to enhance, to share the knowledge with the guys which are basically present in that field and want to enhance the knowledge. And it will also help me to enhance my knowledge through your questions, through your different uh, experiences, because most of the people have joined me are the experienced guys. So it is a short intro from myself. So we will now move to the sessions. Basically, I will give you the short intro of that sessions. Like these are the 20 classes. Yesterday we have to start the sessions, but due to the traveling issue, I can't start the first class from the Monday. So that is why I have start the class from the Tuesday, and your last Monday class will be rescheduled on the next Saturday, if you are okay with that. So in that session, there are the 20 classes, Monday to Friday, 5 classes per each per week. So in first 5 classes, we will do the different projects on the SketchUp software. Then we move on to the next week for the cable sizing, in which I will let you know how we will do the cable sizing for the string cables, LVDC, MV cables, and other thing, MV and LVAC cables. Through the thermal assessment, I will let you all of mm, you guys give the knowledge how we will do the thermal assessment. Basically, in the local level, we don't need to perform the thermal assessment of the cable on the softwares, but for the international clients and the international consultants will require that specifications. Yes, Mr. Greg, I am recording that session. No issue. I will provide the recording. Okay, then then. the thermal assessment is very important factors. So I will give you the short, like one class for that purpose to give you the knowledge and how we will, what is the importance of that thermal assessment and why we are performing that thermal assessment. Give the intro of that softwares and that perform one project for that thermal assessments. Then in the third week, we will do the PVsyst software simulations, data sheets. We will study the data sheets of the PV modules, inverters, and other thing. Mounting structures, I will give you the intro of that things, and then we will move on to the PVsyst software, the proper simulation, how we will put the losses, how we will do the 3D shading analysis, and other things. And in that last sessions, last five classes, we will do the different projects. In the previous sessions, I have just given the software like in that way that I have just given the intro of that software and do like the small projects, not the major one, but in the last classes we will do the one projects. But as per the the feedback I will get from the different students in the previous sessions that most of the peoples have suggested me that I have to do that on that basis. I will do on regular basis. Just in one class, I will give the intro of that software, like the SketchUp software. What are the basic icons and the tools that we need to use? And next 3 to 4 classes, I will do each day one projects separately. Then this will give the most beneficial and most knowledge sessions. That feedback I will get from the my previous students. So that's why I just need your input on that basis. What is your input? As we just give the intro of that software in the just first class, and then we'll do that projects one by one on each day. What is your suggestions? It will be okay, or we will just follow the previous one, just the detail one like the softwares, other things like the what is your suggestion? Any suggestions, or I will just do as per my experience?
I think each day one project, and also yes, by your experience, because you probably have some tools and
Okay,
few
okay,
doing
okay,
things.
okay. I think I think we will do the project based because in that project based we will just do and practice the tools and icon also. So that is why we just follow. But in the first class, I will explain the overall icons and other things of the software. And then from the next classes, we will do one by one, each day, one projects. Okay. So I'm just sharing my screen. So, okay. So, so that is basically the overview. Just the course overview. Just I have just explained the things, how we will do the cable sizing, the PV component, and other things. I'll just give the intro of that course to all of you that we will do each week one by one course, and then I will give the overview of that component, like in the data sheets, in the PVCs, in the AutoCAD. I will do one by one in each things in parallel. So we just now move on to the basically most of the people you are very well known about that the solar energy is basically get from the sun that converted into thermal and electrical. power to power homes, business, and devices, most widely used in the PV system for the electricity generation and clean, renewable, and abundant energy. So that is just a small intro of the solar energy systems. Basically, that energy will get from the sun that converted to the thermal electrical energy through different processes. Like in the electrical energy, how they will convert it, just the sun energy strike on that solar panels, that they will accumulate the convert that thermal to the electrical power in the form of the DC energy, and then they travel to the through the power cables, and then they will reach on the inverters or the combiner boxes, and then these inverter will convert that DC energy into the AC power, and then they will travel through the transformer and then to the home appliances and to the grids. That is the basically the short process of that solar energy. So when we are just see that this is the process, like the solar panels, the electrical, the thermal or sun energy will strike on that, they will convert into the DC energy. So here is the solar panel, which basically do that process. Those solar panels, we have to know about that solar panels, like the data sheets, what they are basically, what is their efficiency, what is their current value, what is their voltage value in the operating level and the open circuit levels, and then they will travel through the power cables. So we have to know about that power cables, how we will do that sizing of that power cables, and then they will reach out to the combiner boxes in case of the central inverter. When they reach out that combiner boxes, we have to know about that their connectors, their uh, load break switch are the breaker sizings, their protections like the surge protection devices and other things. We have to do that sizings also properly, and then that they combine the different strings. And now, what is the string? Basically, string is the combination of the solar panels. They are connected in the series formations. In that formation, the current value of one solar panels will travel mm, in the whole strings, but the voltage will be add up of the different panels, number of panels connected in that series portions. So then when they are reaching out that strings at the combiner boxes level, we connect the different number of strings on one combiner boxes. We will add that at that level. Here, what will do basically that strings connected in the parallel formation. Now, in the parallel formation, you know that in the parallel formation, current will add up and the voltage will be remain same. So at that level, the current will become the multiple of that number of strings to the parallel connection of that strings. How many number of strings connected? So here we will multiply the number of strings connected in parallel in one combiner boxes to the maximum the operating current of that one string cable, one string. So uh, here we will decide on that current basis, we will decide the rating of the LBS, load break switch, or the fuse, or the breakers, which will be preferred through the consultant, through the client, that they will require. And that breaker levels we will do, and we will connect the power cables in the form of LVDC. Basically, here the voltage will remain same, but the current value will add up through that. And we have to increase the size of the cables to carry that current, to carry that voltage, to reach out the inverter level. Where when they reach out the inverter level, the DC power will be converted to the AC power through the inverters. So in that between, we have to design the LVDC cable sizes. When the inverter level they reach, we have to analyze that the fuse, the breakers will be installed in the inverters. They are okay, or we have to raise the concern to the manufacturer of that inverters. And then when they convert that power to the AC power, They will also travel through the power cables in the form of LVAC cables, and they reach out to the transformer or LV switch gear. In the LV switch gear, the AC different inverters will connect in the form of in the parallel connection on one LV switch gear, low voltage switch gear. And then here we will add up these power and convert into the one form, like one collective power, and then travel to the transformer. The transformer will step up the transformer and will go to the that power will go to the grid level. So that is the main basically process, and we have different component there, and we have to design that component with the precisely, with the optimization, with the proper calculation through the different international standards that will be followed through that process. Now we move on to the next sessions. In that, there are the three type of the solar system basically are used in the local market, and that in the system. Basically, the type of the system will be decided based on the inverter types. Inverter types. So here we have three type of inverter. One is the grid tied, on grid or grid tied. The other one is the off grid or standalone. The third one is the hybrid system, grid plus battery. Now, what is the difference between these three systems? On grid, basically, they have just two sources. One is the grid, and the other one is the solar systems. They will combine that two source of energy in at one level, one inverters. Both will be connected on one inverter. That inverter will call the grid tied inverters, and they have the capability when the system will shut down, grids will be shut down, your system, solar system will automatically stop the working. They will not provide the power to the home appliances. So, what is the reason? What is the reason why when the grid connected system, the grid will cut off, your inverter will stop the given the production, given the output? What is the reason? I need your answer from your side. What is the reason why right inverter will stop working when the grid is off? Guys,
It will
I need from
it will stop
yes.
working because and the grid normally stops due to the maintenance issue. And for the security purpose, this can be one reason. And another reason can be that the on-grid inverters may need some power for its own. Is it right?
Okay,
I don't know.
okay. Any other reason, like any topology will be used in the grid tied, or any specification will be used in the grid tied inverter? They on that due to that specification, they will stop the function. Yes, Mr. Ahad. Basically, I have the question that what is the reason why the solar grid type system will stop the production or stop the output power of the grid type inverters when the grid is off? What is the reason behind that?
Because some amount of ampere inverter required to work its own to convert the
So,
current of DC into AC. When
sorry,
they
sorry,
can't
sorry.
get that, I said because
I d-
some amount of ampere inverter required to work to convert the current of AC in, sorry for to convert the current of DC into AC.
I think you are missing some main point, Mr. Greg. Your answer.
I believe it's to prevent uh, ice landing. That's
Yes,
accidental feeding of
that is
grid.
yes. That is the main reason. The anti-ice landing uh, property of that inverters. Basically, Mr. Kazi has given that answer, but specific to the anti-ice landing, they will not refer, but they give the good answer that due to the maintenance issue, because the grid tied inverter will give the feeding back power to the grid. When the grid is off, maybe it will be due to the maintenance issue. When the inverter will give the back power to the grid, and some people will work on that in that area, and they will damage due to that issue. So due to the anti-ice landing uh, property, or uh, that inverter will stop working. So
But sir,
uh,
as you said that inverter stop working because it work on a back feeding. So if there are some kind of a maintenance going there, so there will be a harmful. But there are some type
yeah,
of hybrid inverter also that work without battery, work on a single source of a solar and also on a back feeding. But that inverter doesn't go off when grid is off.
basically, basically, I will give you that answer. Basically, when the inverter in the form of the hybrid, they will, when they will not getting the grid, they will not getting the grid, they will not feed back. They will just circulate inside that options. Hybrid inverter basically, when we connected the battery or not, but they will not get feedbacking back to the grid. They will just operate the loads. But in the grid tied inverter, specifically because we are not connecting and they have not the property to connect the battery, they will only the two options. They basically, uh, uh, the answer you have just given that due to the current, basically grid tied inverters has one reason is anti-ice landing. The other reason is that they need second source of the energy. So when the grid is off, they will stop working. Uh, is the alternative way is that we will give that the second source through the like the generators powers. We will give that source. They will stop not stop working. They will do that. They will consider that like the generator as a second source, and as a consider as a the grid. But the issue is that when they will feed back to the generator, they will burns. They will it will be harmful for that for that generator. So here we have to just install the zero export devices, which they will cap the current value at the minimum load which are running at one phase. They will stop the protection through that uh, zero export devices. They only produce or convert that power DC into the AC, which is basically require and compare with the minimum load. So that is the second reason. One is the anti-ice landing. The other is the second source of energy, because they require the second source of energy. So in the hybrid system, basically they will run on that through the like on the battery systems. That is why they will not feedbacking, and they will uh, working in that phase.
Hello.
Yes, Mr.
Actually,
Kazi.
in some cases, we have seen that in our country, some factories they have only the generator, they don't have any grid, and they want to install the solar panel. So we have seen this kind of scenario. So will you teach us in this design about
Uh,
design with the only
regarding
the battery?
the zero export device.
Yes. Only the generator, no grid presence.
Yes, basically in that session, because I will just one thing explain to you that I have just basic idea of that. How will they will stop that working? But in details, mostly I have seen in my country. that there are the different vendors. They will install that zero export devices. And we also seen in our that international project, which I'm currently leading as a project lead in the South Africa region, which is basically in the mines area. And here they have the feeding issue. So here they are also installing the zero export devices, but on the 633, I think 63 bus bar sides. So here I just give you the basic idea, but in detail I don't have any knowledge about that. Like in the detail how they will work, how what are the component they are used in that one.
Okay.
Okay. So we will move on to the our next session. So off-grid system is just only the standalone system for the small level projects, small levels on the remote areas where we don't have any grid options there. We just install the off-grid inverters, off-grid system. They will just run on the two things. One is the solar system, other thing is the battery system. Basically, the solar system in daytime, solar system will run the load and also charge the batteries. In the night time, they will run their load on the battery systems. And the third one is the hybrid system. Basically, is the combo of both the system, the grid system, battery, and the solar system. Basically, in that case, the solar system and grid battery available. When the load is running in the low level, uh, mm, the like I will say that I want to say that the priority is basically the solar, then the grid, and the battery. Like three are in working in the parallel. When solar and grid will run the load, and in parallel, they will charge the battery also. When grid is off, load will running. They will run the battery and the solar will run the load. And if the solar is on the higher side, mm, through the load, from the load, they will also charge the battery in parallel. They are working in the parallel things. So when the solar system amount is low is much higher side, they will charge battery in parallel, and also they feeding back the unit to the grid. Also they have that options systems. And the core component, the PV systems, solar panels, then inverters, the cables, the mounting structures, the transformers, the LV switch gear, the RMU side, the units, the grid systems, main components, cables, balance of the systems, like the SCADA system, other things. They are the basic core system, the core component of that PV systems. Then the balance of system components, the DC combiner boxes, AC distribution boards, site protection devices, earthing lighting protections, fusing circuit breaker isolator, cable tray, glands, and other things. They are basically the balance of system components. So here I have just explained the combiner boxes. The combiner box is basically used to combine the different number of strings in one output form. And the AC distribution board, basically, we connect the different number of inverters in parallel at one level and convert into the form of the one output form. Then the surge protection devices like the SPDs, they will use the surge protection devices to protect the system from the cloud surges and that issue. Then lighting and lightning protection, earthing and lightning protection. Basically, lightning come from that in from the skies, and that issue will we will protect through the lightning finials, the lightning masks, and the surge protection devices. And then the earthing system is basically due to the error, the fault that will come to the shorting of some component with the live part, due to some the part some will connect to the ground, and due to the insulation issue and other things, we will give the fault current will travel through that path. We have to protect the system from that fault current. We will give them the earthing system. Basically, the earthing system will, in the form of the mesh, in the form of the separate earthing system, that basically the fault current will travel through that earthing system and ground it. That's the fault current to protect the system. Then fusing, circuit breaker, and isolator. Basically, the fuses and circuit breaker have the same philosophy to protect the systems from the uh, short circuit current and the other things, the fault current system at the small level. The isolator will isolate the system from two parts of the systems. Then cable tray will use to lay the cables uh, on the ground, in the on the wall and other things. And then gland will use to give the path to the cables to the different uh, compartments. Connectors will connect the cables and the connecting points. So here is a just overview of that solar systems. Then I will just move on to the SketchUp software. So basically, this is the basically overall uh, overview of that SketchUp. When you open that SketchUp files, you just see that portion. Create new model. Simple one, architectural, simple, architecture, and art. But here you can see that the difference. Simple inches, architecture inches, simple meters, millimeters, and centimeters. So here you can just uh, you can use the architectural simple, no issue. But you have to just use the same units which you are want to use in your drawings. So here I have just give you the overview, and I just click on that architectural meter systems. Yes, Mr. Ahad.
Sir, could you please elaborate the DC combined boxes system, like how it's work?
Combiner. Okay, okay. Basically, the combiner boxes will be used in our solar systems when we are using uh, I can say that the tubal systems you have seen in the agriculture systems. Here, just the VFD are variable force frequency drives are the Gentech devices will be used. They basically has less number of MPPT tracker. Now, the MPPT is basically the maximum power point tracker. Here we have to just connect the number of strings and number of MPPT trackers. So when we have less number of string connection options in your system, like in the central inverter has less number of MPP string connection options as compared to their power, and the string inverter has more number of string connection options as compared to their powers. So when we have to connect like you can say that 60 strings on one inverter, and they have just option of the 20 strings, 15 strings, they have the options. So what we will do that we just combine the different the strings in at one level, convert it into the one output power cables, and then connect it onto the central inverter. So the device will be used to connect that number of strings combine that strings in parallel form and convert it into the one output power cables. That basically device is called the combiner boxes. Like the junction boxes, you have seen that different cables will connect at one bus bar, and the one output cable will be do that. So the junction box function is just to connect the different number of strings at one level and convert into the form of one string, one output for cable. So that is the main reason, and that is the basically the purpose of that combiner boxes. I think you have now clear that point.
Yes, I got it.
Okay. 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 So here is basically that the SketchUp options. Open that. So here are the overview of that SketchUp file. Here is the toolbox available. You can see that like location, permission, shadow, solid tools. No solid tool. Okay. 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 Wiring that. Yes, large tool set. Here is the option when you just right click on that option, large tool set is available there. So you can see that it is the selection options, select options there. You just select that object, you select the different things. This is basically lasso select, draw selection bound manually to make custom selection. Like this one, like other thing. You can see that. Like I have just one, okay, just push pull that option. Okay. Now I want that one selection, this one, like this one. Okay. Okay. Like this one. Just the portion one. That tool will be used. This is the bucket, paint bucket will be used to paint the different things in your drawings. Like here, I have just given that colors. This one, I will just give that color. This one. Like they have different options, metals, pattern, stones, tiles, color, like the tiles that available. Like you can see that it is like this one. Just click that color, click on that selected options. This is the eraser. You just click on that to erase that option. You just click that. Control Z. I have just to make the component. Basically, component means that you have to make that component. Just click on that. Click on that options. Just give the name. Like I have given that one. Create. And now you can see that it is the component. Now when you click the color to the one box, it basically give the color to the whole systems. Uh, now, when you will increase, like you have different component and you have copy that component. Now, when you will change in that component, you can see that I have just click on that one option. They will just uh, change the other component which you have just copy that. Basically, the component purpose is that. Then that one is basically the tag options. Like I have just click that one, click that. And then this is the tool, the line tools to draw the lines and other thing straight forward. This is basically the freehand. When you will do that one, like this one, freehand, like this one, you can do that, this one, like I have just explained that. You can see that. So here is the freehand tools available there. Then this is the rectangular, like here you can see the rectangular. This one basically rotated rectangular, like here you can see that here, like rotating one which you want to make. Then this one, the circle, like circular circle. Then this is the different options, polygon and other thing. Then the arc options, this one, this one, the arc options. Then this will be the 2 point arc, this one, like the 2 point arc. Then this one, the 3 point arc, like 1 point, 2 point, and then the 3 point. This will be the pi options, like here, this one, like this type, this one, the pi type. Then this is the move command, like we have just one rectangular there. I want to move that here. Just click on that, move that here. This one, the move command. Then the push pull to, this is very important tool. Just click on that to give them the height to the structures, to the buildings. Then this is the rotating. Just click on that in that area and then like this one. We just click on that, rotate that, select that point, select this one. Okay. Like here, I just click on that in that rotation option. Then this is very follow me command. Basically, like we will do like that, and I have to give the 2 point arc, like here, here. Follow me basically. This one, this one, like so. This is the scale options. When we will just click on that and scale that option, like here, here, scale up and down. Then this is uh, the offset command. When you give them the same, like outside or inside, this is very important tools. We have to give them the height and other things. Then this is the access no issue, flip one, like this one. Okay. And just that one. Like I will select that option, flip that. You can see that this will be flipped to that one options. Like here, you can see that. they will be flipped that. They will rotate their directions. Then this is the measurement tools. You can here you can see that they will give the height, that 115 meter approximately. Then this is the dimension options to mark the dimensions to the buildings. Then this is the D options to check the that angles, like what is the angles. Here is the options that. Then the tagging options. Here basically I have tagged that options. Then that one, the section options, different sections options, symbol two here. Yes, this is the sections cutting. Basically, this is cutting section is mostly used in that in the civil drawings, but in this our things is not much more will be used. This is the uh, col like the text options that like here. I've just mentioned that text GT, place that. And then this is the very important. Here, just I have just click on that, and we have to just rotate that option in that direction. This is then the palm. You have to move that full screen, uh, screen up and down, like down, up, other things. Then we have yes, Mr. Greg.
Um, I have access to SketchUp Go, so maybe you can touch on what the difference are with the SketchUp Pro, or what will I be missing when I'm using SketchUp Go instead of SketchUp.
SketchUp Go and SketchUp Pro.
Yes.
Rather, basically, I have just used that simple free version. I don't use any pro version, I think. So I don't have any basic knowledge of that one. So that is why I don't want to give you the lie to you regarding that. That is
Okay.
why just okay,
Okay. No worries. No worries.
okay then. And then there are the different tools that the different extension I have just installed in that options, like that for the pipes. This one for the other one is like shadow. This one is a for the shadow, like they give the shadow options in that region, what is the effect of that shadow. Then the scallion options that to install the PV panels, and then the save option that, then the files when you will go to the geolocation to add locations. When you will go to that, you just give the like here I have just given the coordinate, search that and select that options and import. Like you can see that they have imported that. Here you can just search that option and place your systems. Then you have to export options like 2D, 3D, which section you want to export that option. Then you have the camera options, the standard parallel projections, and then you have to like the top view, the bottom view, uh, then you have the front view, then you have back view, then you have like different options available, right view, left view. So you have isometric view also available. So what view your client is asking, you will give them that options. And then here is the right, left also available that options in that. way. So here is the extension options, extension warehouse and extension manager. Whereas you can search the different extension, free extension like I can show you. Like you can search here the different extension. Like here I have just installed the different. Uh, so other one is basically then the warehouse window, the 3D warehouse is basically that one. We will use that. How we will search the different component. Like I will just search the cables. You can see that we have any cables available there. Like you can see that they have just different cables available there. So here you can use in your drawings. It is very important. Then the extension manager, you can install the different uh, extension there, like the wild wire tool, wild other things. I have just fence maker, other things I have just used that options. So here is the tagging options that available. We will use that in our projects. That shadow options there, and this is the just overview of that software. We will use that software inshallah in the tomorrow class. We'll just tomorrow we will design a 50 kilowatt systems and solar systems, uh, the rooftop systems. Okay. So here is just for the today. Now I think you have any questions you can ask. Then we will end up our today class. No question? Okay, guys, thank you very much for the joining that class. I think okay. So I think you have get the knowledge. Try to install the free version. If you have the pro version, that's very good. If you have don't have that software, kindly install that software from the um, www.getintoPC.com. Uh, Basically, you can check that software from that website. Get into PC. Free version are available there. You can uh, that softwares from that website. Mr. Kazi, if you have any question, you can ask. Then we will end up our class.
Which extensions which need to be installed in the SketchUp? If you
Version,
can give the not version, the extension that you showed us in the which extensions is
basically,
required.
basically, we have to install the one main extension, which is Scalian. But at that time, the Scalian has limited the free version up to the just 10 PV module installations. Here, the software which I have just running here, the Scalian is installed, which is mm, we can install the PV module up to the maximum limit. But now these days, the free version just have the option of the 10 PV modules. So we have to install the Scalian options. Uh, Most probably this will be used. And then other one is the uh, Scalian and fence maker. This is very important. The two extension you can install most probably. And version in the 2023 they have the geolocation option available, but in 2025 geolocation is option is not available. So what soft version you want to install? No issue. You can install. We have to practice that. Okay, guys. See you tomorrow.
Okay, inshallah. Assalamu alaikum.
Assalamu alaikum. Assalam.